Yo, what's up, guys? Welcome back. Another video, another day. Hang on. Sorry, my friend texted me. Another video, another day. We're gonna do a few problems. I don't know what problems we're gonna do yet, but we will take a look. So, first of all, we're gonna do our Pokemon of the day. So 48. So we got a Venonat. Let's get our Venonat sound. Venonat. There you go, man. Translate that to English. Sweet. But yeah, that is our Pokemon of the day, a Venonat. Let's check out the Leetcode problem of the day. Curious, what is a bi-weekly contest? I'm curious, like, how does this work? I'm so confused what a bi-weekly contest is. What is a bi... This kind of conversation held every 2 weeks where users are presented with a set of algorithmic problems to solve with it. Oh, interesting. Ah, man. Damn. Alright. Let's do a couple problems. Getting distracted. So this is our product of lost key numbers. Designer algorithm that accepts a stream of integers and achieves the product of the last k integers of the stream. It enlarges the object with an empty stream. Appends an integer number to the stream. Turns the product of the last k elements in the current list. You can assume that always the current list has at least k numbers. Returns the product of the last k numbers. Okay. The product. Okay. My dictionary is equal to dictionary. And I think that's how we initialize it, right? And then we just solve it on my dic. Sorry, we wanna. Oh, ow! Product of numbers. Initialize the object with an empty screen. Oh, man. I guess what are we initializing an array? So is equal to this, right? With an empty stream. With an empty stream. Is that an array or is that something in... What is an empty stream? I don't even know what that is, to be honest. Like a stream of data. think, to be honest, I think it means just an array. Product of numbers, add, get product, add, get product. When a zero number is added, clean the array of prefix products. Okay, here we're doing self dot. Num.append append num, I think, get product, we want to get the last, turns the product of the last k numbers in the current list. You can assume that assume that always the current list has at least k numbers. Last k elements Python. Knums. Let's just run this. I don't even know what I'm doing here, to be honest. I'm just playing around. What is going on here, bro? Thought I have to initialize an array, bro. Did I read this correctly? Design an algorithm that accepts a stream of integers and retrieves the product of the last k integers of the stream. Implement the products of numbers class. Initialize the object with an empty string. I think I'm kind of confused about what to do here, to be honest. key. I'm just so confused what this is doing, to be honest. Like, okay, so apparently we have to initialize a list with 1. Okay. We just have to use a self keyword. I didn't think we had to use a self keyword in this. I thought we were initializing it here. Okay. Oh man, my back, dude. You know, I'm gonna leave this because I think this is telling me. Let's just initialize an array here. Alright, so we initialize our array. We append. And how do we want to get the product, right? So we want to return the product of the last k elements in the current list. You can assume that always the current list has at least k elements. So what, you'd have to loop through the last k elements? Would you loop in reverse? I guess we could do that. Let's loop in reverse. How do we loop through the last k elements? For God, how do you loop in reverse? How do you loop in reverse? Okay, honestly, I always forget how to do it. For in reversed nums through k elements. Is that how you done? Try invest. Oh, okay. Nums k. Guess the last k elements. Okay. Using the range in reverse. What do we want to do? We want to do the product, right? So I guess we'd have to initialize the product here. Product is equal to 1. We do product is equal to time. I think it's times equal to nums I. Want to return the product. Name nums is not defined. You mean dumps? What? Why is it not defined? Oh, we got the self keyword, I think. is out of range. I don't think this is gonna work either. That was stupid. Why did I do that? Oh, no, it ran? No. That was definitely wrong. So what was our thing? It's out of range. Index is out of range. Why would it be out of range? Self.nums I. Getting a list index out of range. Oh. Okay. I'm mistaken it. We don't need this. I thought this was for I in range, but we're using reversed. Okay. So it's just self.nums. Can't multiply sequence. Oh, we just do I, sorry. That's what I meant. Okay. Darn it, we're getting some output. Okay. And we're not adding anything. Why aren't we adding anything? Are we actually appending? I don't know. Are we actually appending? Who knows? I don't know. Let's print L self.nums. Okay, so we're actually appending the values, right? Okay. Yeah, so we're appending the values. So something in here is not working. Five times 4 is equal to 20. 2 times 5. 2 times 4 is equal to 40. So I need the last k element, so I need the minus there. No. Was that really the issue? No. But why would it be returning nothing though? Nowhere. I think I'm gonna have to do it a faster way, which I think for I in range. Just not equal to self.nums minus I. Self I in oh shit. That's why. Will this make it any faster? I don't know. I mean, technically this is O of K. I don't know if the slicing was exactly O of K, but let's take a look. Nope. So what? It doesn't. Like, bro, why does it? Can you remember both get products and add to work in O of 1 time complexity? This would be O of 1 because this is append, right? Right? Or am I tripping, right? I don't know. I think appending is O1 because you're adding to the end of the list. It's append O of 1. Okay, yeah, I was right. How can we implement this to be O of 1? I don't know. Honestly, I'm not really too sure how to implement an O1. I kind of wish it came up over here, but that's alright. the size, the length of, okay, if size. So we get the length. If the length is less than k, we return 0. Otherwise we return self.prefix -1. The last one on the list, divide by self.prefix product size minus k minus 1. Okay, so they're telling me that, okay, so if num is equal to 0, we want to self.nums is equal to 0, right? Or 1. Or yeah, self.nums is equal to 1. Otherwise, else we want to self.nums.append. Sorry, this needs to be a, okay. What are we appending? We're appending num times -1 times num. We want a 1 in here to initialize the array. So we're constantly appending the product of the next one, right? So then, okay, so then I understand here that we take the last product and we divide it. Ah, that's a smart way to do it. I didn't really think about that. I mean, here we take the size. Length is equal to the length of self.nums. Right. Then we say, well, if length is greater than or equal, sorry, is less than or equal to k, we just, well, we return 0, right? Yeah. Otherwise, we return the self.nums -1 divide by self.nums. Then we go from what is it? I don't remember. Size, length minus k. We need a -1 at the end, but I'm just curious to see how this runs. Interesting. Just some freaky math, I guess, goes on behind the scenes. Interesting. Okay, let's jump into a different problem. Try to smash out a couple of my there was another traversal one that we needed to finish. I don't remember. In order traversal? Is it that one? Okay, let's do this one really quick. I think we can smash this one out pretty quick. Oh. Oh my gosh, dude, my back. Man, my back's still sore from yesterday, dude. I don't understand. Okay, one, two, three. So binary tree in order traversal, even though we eventually return the in order traversal of its nodes. What is an in order traversal? I think it was starting at the root, right? Okay, we visit the left subtree recursively, traverse the left child, visit the current node, process the node itself, visit the right subtree. Okay, so one, two, three. Okay. Another DFS, right? We want stack. Sorry, no stack. We're gonna pass in our DFS function, DFS, pass in our root. Passing in a root, and then I guess we just want to return res, right? I guess some sort of res array or something. Let's check out our post-order traversal. Okay. Yeah. Well, this we see null node. Just want to continue. So if not, no, we continue. And then what you want to do, which is also a base case, right? And then we want our cursor case where we loop over. So in this case, how would we do it if we want to traverse the left subtree first? Well, TFS node.left. TFS. It's just the way that I'm thinking about it. I guess we just want to do like I don't think this will work, but we'll see what this runs. To return, dude. Shit, we need a val. A val. Let's cut that out really quick. Bro, no way. Bro, no way, that's it. Bro, what? We did, if not node, TFS node left, then we append node.val. Then we check node.right. So a little quick stack approach really quick. Stack is equal to, let's put our root inside, then we stack, we pop from our stack, so this node is equal to stack.pop. If not node, then we just continue. So our base case, if node is empty, otherwise if node.left, TFS node.left, then we res append node. Res equal to this, we append the node. Node.right, and we I don't even think we need these if statements, bro. I think we can just stack.append node.left. We need to return. Let's return our res. I think it's going to be infinite loop. I got some order messed up. Stacked up. Oh. Bless me, bless me. It's gonna be so cold. Oh my gosh, dude. Just give choice the deadline decision to retire. Damn. Anyway, what are we doing wrong here? So we want to print left, right in auto traversal. At the moment, we're popping from the stack. We're processing this value that's not node, stack.append, node.left, res.append, node.val, node.right. So we're going left, and then we're appending the root. But the root is still 1. So maybe we... Bro, I'm so confused right now. Like, seriously, like... Bro, I swear if this works, I'm just so confused. Like... 1, 2, 3. What? Still appending 1, 2, 3. I think it's just the order of this is. I don't know. I thought it was the order. What is it? Traverse the left W by pushing all the left children onto the stack. Okay, we wanna. And we want to. Okay, I think the way this is working is that, so our root is currently the current, right? So we go through while current, stack.append current, right? So current is, our root is our first value, right? Then we append everything to the left. We append everything to the left, right? And then we go, while current is something, and then what we add current in. While current or stack, well, we got something in our current. So while our current is root, right? We start at root. While current, stack that append current. We append it, we move to the left. We append it, move to the left. Append it, move to the left. Well, now our current is null. So it's equal to none now. So then we go back. What then we do? Well, current is equal to stack.pop. Then we pop from the stack. We're still at this value. Right, we append it to our thing. Then we go, well, current is equal to current.write. Let's do paint. Ow. So we started our root. Let's do this one, right? So we got our stack, right? Okay, so we started our root, right? We add 1, right? So let's add 1 to our stack. We got 1 here. Oh my gosh. To process 4. We add 2, right? Well, current stack not append, right? So that's our root. Then we move to 2. We append. Our current is 4, so we get to 4, right? So we append all 4. Though 4 has no left child, so process 4 and pop from the stack. Process 4 and pop from the stack. So we pop 4 from the stack, and we append 4 to our array. Right? Back to node 2. We process node 2 and pop from the stack. So we process node 2, and then stack is equal to 1, right? So let's pop that. Move to right child. Oh my god, we're missing one part of the code. Current is equal to current.write. If it exists. Oh, dude, I'm so stupid. Oh my god. So we go to 2 here, right? Current.write exists, so we go to 5, right? So now we're at 5. And then we go back into this while loop, right? So we're at 5. So then our stack is 1, 5, right? We go back here, well, while current is, you know, something, not 0, we add 6, right? So we go to 6. We add 6. Then we notice, well, you know, current is equal to current dot left. It's null now, so then our current is equal to stack pop. So we pop 6 from the stack. We add 6. Just want to make sure this is right. To node 6, right? We add 6 here. So we process 6 and pop from the stack, right? So then we have stack 1, 5. Then we're back at 5, right? Well, then we have zero current is equal to current dot right, right? So then we put in 7. We got 7 here. Alright, so then we add 7 to the stack. We pop it. Because now we have no children. So we're out of this while loop again. We pop it, right? Pop from the stack. So we're at 4, 2, 6. Oh, you fucked something up. Okay, we're at 4. Oh, jeez, now we're lost. Oh my god. Okay, we're at 4, 2, right? Okay, back to node 2, right? We're back at node 2, where we do current is equal to current dot right, and we see 5, right? So then we add 5 to the stack. So then our stack is 1, 5, right? Move to the left child 6, okay? We add 6 to the stack. Node 6 has no left child, so process 6 and pop from the jack. So we process 6, we pop from the stack. Stack is 1, 5. Right now, yeah, and then we have 4, 2, 6, like what we had before, right? We're at 6, you see there's nothing, so we go back to 5, right? So then we process, well, current is equal to current dot, current is equal to stack dot pop, res dot append current dot val, right? Then we're back at 5. We have our current is equal to stack dot pop. Process 6, we res dot append current dot val. The current is equal to current dot right. Equals to current dot right. Current is equal to current dot right. Well, there's no current dot right for 6, right? So we current is equal to stack dot pop now, so back to the top of the stack. So we pop 5, right? And we add 5 here. And then we have, well, stack dot pop, res dot append, current dot val, current is equal to current dot right. Current dot right is 7. So then we have, alright, well, while our current, stack dot append current, right? So we append 7. Current is equal to current dot left. Well, it's null, so then we come over here, then we pop. Okay. Then we res dot append 7. Where are we at? 4, 2, 6, 5, 7. Alright, we move to the right child 7. Well, it's none. Right, so then we can backtrack all the way back. So then we do current is equal to current dot pop. So then we pop 1 from here, right? So all the way at the bottom we have 1. And we res dot append 1. But then we see what we got of dot right. So then we go, well, current dot right is 3. So then we add while current stack.append current. So then we append 3. Current is equal to current left. Well, then it's null. So then we come back here. Oh shit. And then we have 3 in the stack, right? That's when we pop 3. Pop 3. And then now, yeah, we pop 3. So now we're back at, what are we after that? We got 8. Alright, so we're at 3. But then we go back into the while loop because it's not current. Then we see, okay, then our current dot left. Oh, sorry, no, we popped, no, my bad, sorry. The result move to right child 8, right? So we move to right child 8. Well, we see that it's not null. So then we add 8 to the stack, sorry. Then we add 9 to the stack. Then we add 9 to the stack, and then we pop 9. 9, yeah. And then we pop, add 9, yeah. We add 9 to the stack, because then we pop it, because it's now null. We pop 9, we check if it has a right. It doesn't, so then we pop it. Count is equal to stack.pop. Then we pop again. Then we have 8 as our last number. Is our in order traversal. God, that's confusing. We got it though. Took a lot longer than I thought it was going to take, but it's okay. Okay. Okay, let's do 2 to 2.5 weeks. Oh my gosh, dude. We should do all the easy ones first. Build our way up. Cousins in binary tree. Maybe we can do diameter of binary tree. There's 2 binary trees. Let's check out the diameter of binary trees. Okay, given the root of a binary tree, return the length of the diameter of the tree. The diameter of the tree is the length of the longest path between any 2 nodes in a tree. This path may or may not pass through the root. Bro, I'm so confused. Should it be 4? So the root doesn't count? Okay, damn, dude, how the hell do you know? How the hell would you know, dude? Oh, my back. Okay, the diameter. So how can we think about this? I'm just confused how this is 3. 3 is the length of the path 4, 2, 1, 3. Diameter of a binary tree is the length of the longest path between any 2 nodes in a tree. This path may or may not pass through the root. You would think this is 4, right? Like, bro, what? Like, let me look at the discussion. Of diameter, yeah, I don't understand that. It is difficult to say. Instead, longest path. From the right is a mod. Acceptance rate is only 62%. I mean, I'm just trying to understand the problem question. Like, how would we even go about solving this problem? I don't really know. Like, I mean, the only way I can think is that you start at the root, you traverse, keeping the count. You know, if our base case would be, well, if, like, you know, the 2 children are null, if left and right is null, then you'd save the count. That's the max where you can go from the root, but then you can go from 3. Go 1, 2. Like, how would you traverse from a different area? Like, if you don't have access to the root, like, how would you know, like, the way to traverse the other way? That's the thing. I mean, I can easily write an algorithm that can, you know, count the depth from the root, but it's the more difficult part is, you know, starting at 3. Like, how can you go like 1, 2, 3 from, you know, starting at 3? I don't know. Have I done this problem? No. Okay. Be nice to have like some hints or something, no? Like, potentially. Bro, I was literally thinking of this solution. Okay. Screw this. We're going to write my solution. FDFS. What we want to pass into the DFS is we want to pass, well, the node, right? Yeah, okay, got that. So let's do that. Let's pass in our root node, right? So we do DFS root. We want to return, let's say, our max num, right? We can create our max num variable out here. Max num is 0. We go through, right? So we do, well, if node dot left and node dot right not node dot left and not node dot right, then we want to update our count, right? So we want to do, well, okay, TFS node dot left, TFS node dot right, right? Recursively calculate the height of the left and right subtrees. Left height, TFS node dot left. They do a different way. They're kind of doing it. I'm kind of thinking. I'm kind of thinking of like passing an account in the parameter here. If not node.left and not node.right, then we update maximum max equal to max, and then we do like maximum count, right? This is our base case, right? This is our base case. In our recursive case, well, if not node left and not node right, maximum. Node left, defs, node left, count. Let's do like local count. Call this local count. Local count. This is the way I was thinking about it. This is obviously wrong because I think this is counting from the root, honestly. Local count. Then we have our node.right, DFS, node.left, local count plus 1. Can we just increment here? Well, if node.left, right, then we can increase local count plus equal 1. This wouldn't work because what? No, I don't think this would work because I think it's counting multiple different things here and we're comparing like shit, we probably need to pass in maximum too, I think, right? You know, I don't think this will work. Set down, find outside, local count is being passed to the function, but its value isn't reset for different paths. That's what I was trying to say, but I didn't know how to say it. You requested calling DFS account for the right child, but it should be. This is likely causing a traversal of the wrong tree. Calculate the height of the subtrees at each node, compare the sum of the heights to the left and right subtrees, and update the diameter. Ah, shit, dude. Okay. So we have our maximum, right? This is what it's telling me. not node, return 0. Get rid of the local count. If node is none, return height 0. Right. Have our recursive case. Now we have left underscore height is equal to DFS dot left. Right. Right underscore height is equal to DFS dot right. But how is it counting here? That's what I'm confused about. I don't understand how it's counting. Left height. The diameter of this node is the sum of the left. Okay. Alright. Oh, sorry. Right underscore height. I swear we did a similar problem with this one, man, like in the past. Left underscore height. Right underscore height. Plus 1. And we call DFS on the root. Right. Turn the max on. We add self dot. Self dot. Self dot. Self dot. What is the difference here? Oh shit. Plus right height. How the hell is that going through? Okay, I gotta. How is this? I don't understand how this is keeping track of the height. Unless I was thinking that the height is like here or something. Self dot max on left height plus right height. Just keeping track of the height. Right underscore height. Zero, zero. Like, right, I don't get it, dude. Turn max, left height, right height. Leetcode's got a video. Let's take a
Hey
look at
everyone,
this.
welcome back, and let's write some more neat code today. So today let's solve diameter of a binary tree. So we're given a binary tree. All we need to do is compute the length of the diameter of the tree. And what exactly is the diameter? It is the length of the longest path between any two nodes in a tree. And this path may or may not pass through the root, so it doesn't have to necessarily pass through the root. So let's look at an example. So given this tree, the diameter of it is 3. Why is it 3? Because you take a look at the path from this 4 all the way to this 3, and that runs from the root 1, right? So you go left 2, and you go right by 1, right? 2. One, 2 plus 1 is 3, so that path is 3. That's the diameter. Now, it's the longest path, pretty obviously from looking at the picture, but what are a couple other diameters that aren't necessarily the max? Well, look at this. If you go to its left, that's a path of 1. Go to its right, that's a path of 1. So the diameter from here is going to be 2. And what about this? If you look at, the left and right are null, so
I don't know how to respond to this text.
the diameter from that is actually 0. Same for this 5. The diameter running through this is 0. The diameter running through this is 0. And technically this is also a possible solution because the diameter through there is also uh, 3, right? You go here 1, you go here 2. So what would be a brute force way to solve this problem? Well, let's take every single node and consider it as, let's say, the topmost node in that diameter. So let's find what's the max diameter from here from this node 1? Well, we want to go as far down right as we possibly can. We want to find the lowest node on the right side. Well, we see this is null, right? So the path on the right side is going to be 0. That's the maximum on the right side. What about the left side? Well, we go down to a 2, that's good, right? We went down 1 node, and we can either go down 3 or 4, right? So basically now what we're doing is recursively finding the diameter from this spot, right? So clearly we can see a little bit of repeated work that we can possibly cut down on. But let's continue the example. From here, what's the biggest diameter we could find? Well, we obviously see that both of these paths will lead down to the same level, right? The lowest node could be on this side or on this side, so it doesn't really matter. But what is the length of it? Well, from here, the length is 2, right? And to go from this 1 down to this 2 is also another 1. So in total, this entire side is length 3, right? So we take 3 plus 0 and find that the biggest diameter we could find running through this 1, through this root node, is 3, right? But is that the biggest possible diameter we could find? It's actually not, right? Let's take this 2, for instance, right? We want to find the lowest node on the right side, right? Clearly, we go down to this 4, then we go down to this 6. So the lowest node is 2 edges long. What about the left side? The exact same thing, right? The 5 is 2 edges away. This is 1 edge, this is another edge. So now we can take 2 plus 2 and find that the diameter running through this node is actually 4. That's bigger than what was running through the root, which was 3, right? So this is our biggest so far. And if we were doing the brute force, we'd probably have to do the same thing through every node, right? From this 3, we'd find, okay, this is 0, this is 1, so then in total, the diameter from here is just 1. And the diameter from here, since both left and right subtrees are 0, the diameter through here is going to be 0. And similarly from here, the diameter running through here is going to be 1. Diameter running through here is going to...
This is the brute force. I just don't understand how this is counting, bro. How is this... How is it counting the amount of times that we're... This is so confusing. Turn the max, left and right height. Left height, right height. Okay, we're counting here. Bro. We're counting here. I thought this was outside of the loop, dude. Oh my God. Okay, so we're counting here, right? So we're looping through, going through, we're doing left underscore height is tfs.node left, right? We do our max sum, we check at each, this is our brute force method, so we're checking at each value, our left height plus our right height. Max, return max, left underscore height, right underscore right height, plus 1. Let's just keep watching this video.
It's gonna be 0. But you can see that that was kind of a lot of repeated work, right? First we had to find the lowest from here, then we had to do the same from here, right? So can we do this a little bit? If we do this in a recursive way, we can actually eliminate the repeated work. What we started was top down. We started from here and then we wanted to find the diameter from here, but really what we can do is start from the bottom recursively, right? So find the diameter of these 2 nodes first, right? And I'm just going to kind of visualize it a little bit. It'll probably make more sense in the code. So the brute force way that we did it is technically big O of n squared, where n is the number of nodes in the tree. I'm going to show you how to do it just big O of n, where we only have to visit every single node at most 1 time. So basically what we're going to do is we want the diameter running through here, right? We're going to have a max variable, right? We'll call it max. Initially it's going to be 0, right? So we want what the max diameter is running through here. Okay, to do that, let's first solve the subproblem. What's the max diameter running through the right subtree? Well, clearly it's an empty subtree, so it's just going to be 0, right? Okay, now let's find the max running through the left subtree. Okay, that's great, but now to do that, we have to also find the max running through 3. So clearly we're just visiting every node once so far, right? So let's find the max diameter through 3. Okay, let's look at its right subtree. That's 0, right, because it's empty. And now let's find the max diameter through the left subtree for 5, right? So then we're going to look at its left and right subtrees, which are both empty, right? So the diameter through these 2 trees is 0. So then what's the diameter through this tree? Well, in reality, we can tell it's 0, right? But now when we go back up to here, what are we going to do? In reality, we don't just want the diameter through this, right? We also want the height of the tree starting at 5, and we can tell that that as well is 0, right? And this part might be a little confusing. It'll make more sense in the code, but basically for each of the nodes in here, we want the diameter and we want the height of the tree. So the diameter through here is 0 and the height is also 0. So then we want to find the diameter and the height for 3, right? So first of all, how can we find the height of the tree starting from 3? Well, we want to look at its left subtree and its right subtree, right? Find the height of the max of these, right? So basically the max height from left and right, the max height from these, right? And add 1 to it. The reason we're adding 1 is, see, there's an extra edge here, right? So clearly the max of this is 0 and the max of this is also 0, but basically for convention, notice how this is a null tree. In reality, by convention, we say that the height of a null tree is going to be -1 because the height of a tree with a single node is considered 0, right? And this just helps the math to work out. So I'm going to leave a -1 here saying that the height of this tree happens to be -1. So then what's the height from 3? Well, the max of left and right is going to be 0, right? So 1 plus 0 means 1, right? So we can put a 1 here for the height of the 3. Well, what's the diameter of the tree? We can find the diameter by taking the height of the left tree, so left, plus the height of the right tree, which in this case is -1, right? So plus right, and then plus 1 and plus 1. So in reality, plus 2 because for each of these trees we see there's an edge going to it, right? So this edge, right? And what that's going to do is -1 plus 1, that's going to cancel out, right? This is going to be 0, meaning the height.
Bro, this is a very confusing problem. I think we're going to leave this for another day. Because I just don't understand this right now. We'll be gone for a little while too, not gonna lie. Let's look at it one more time. I just don't understand how it's holding the height. I just don't get that. Like, I know this is cool, you know, recalling the function, but I don't understand how DFS node left is holding the height here. Unless we're like, this is where we're computing the max. Times 0. Okay, yeah, that's what I thought. Now the height of 4 is 1 plus 0, 0. Turn 1 to DFS 2. Okay. I'm gonna reset the code. I understand it now a little bit. I can understand why, how we're counting. I think I'm just tired. Oh shit, my back. God. Let's finish with one other problem. I don't know. Let's take a look at a hash table problem. I want to finish on a good note, so let's there's a problem here. Which one should we do? Present cell after end days. Let's just close my eyes. Oh, so okay, we're here. Let's clear this one. What is this one? Oh, what we did the other day, bro. That problem sucked. Close our eyes. Boom. What do we get? Isomorphic strings. We already solved this one. Let's just solve this one. Screw it. I mean, when was the last time we solved it? August 27th. Okay. Yeah, it was probably in Java too. Yeah. Okay, let's just solve this one then. Give two strings S and T, determine if they're isomorphic. Given two the characters in S can be replaced to get T. Okay. So the strings S and T can be identical by mapping E to A, mapping G to D. Two strings S and T are isomorphic if the characters in S can be replaced to get T. I'm so confused here. So we're not looking for duplicates. We're looking for more kind of like position, I guess. How can we do this? And be replaced to get T. So if E is A, Let's create a dictionary here, right? We loop through if I in S. Well, they have to be the same length, right? I guess if they're not the same length, so I guess we can do that. If the length of I does not equal the length of S, then we can just return false, right? If S does not equal the length of T, we can return false. Otherwise, we create a dictionary, I and S. Well, if I guess we can just map each value to it, right? So, right? Can't we loop through and map all E? The value is A, right? We map through, well, G is the value of D, right? Well, G is the value of D, and we just compare like that. I think that might work. I not in my dictionary, then we just map it, right? Well, my dictionary S my dig I is equal to, okay, we're gonna have to do, I think, in range length S. If I not in my, if SI not in my dictionary, then we do SI, right? SI is equal to, well, it's TI, right? If SI in my ASCII dictionary guess what, we have two things. Well, else if it is, then we just want to do, well, my dictionary SI else if it is, then we want to check, well, if my ASCII dic SI is equal to TI, ci, and we return false. Otherwise, I guess we just return true. Does this work? Okay. Oh, we were so close, bro. How was this true? I'm confused. Bad C, bad bar, bad C. On my dictionary, it assigns B to B, right? And we have A, it assigns A to A. And we have D. So it adds it as B. So then it adds it as B. We're missing an edge case. If I have to check everything for value in SI. Value in dictionary.items. Well, if value in my dictionary return false. Is this how you would do it? I don't know. Values? Is that better? Now it's then squared there. Okay, I'm missing something again. AB. Bro. If S is equal to T, it's untrue. If I got way too many edge cases, I'm doing something wrong for sure. Like, something wrong for sure, dude. I mean, bro. Is there a better way to do it? So long as character from string S have only one map towards character pattern and T, the strings are isomorphic. What am I doing wrong here? I think I'm thinking about it in the right way. If SI not in my dictionary, we make it and put it in the dictionary. Also, if it is, we check, well, Not sure what I'm missing. I should have done that. That's so much better. Use is equal to set. Man, that was one thing I missed. Your solution is almost correct, however, you're missing one important condition. The mapping must be 1-to-1. This means if a character in S is mapped to a character in string T, no other character from S should map to that same character in T. Damn, dude. Oh, we were close. If SI not in char index S, they map it. I guess that's another way to think about it. It's an interesting way to think about it. Yeah, you know, I kind of want to do a sliding window problem. I kind of miss them. Let's go to Leetcode patterns, baby. Let's check out some sliding window problems. Let's do permutation of string. I just pick this one. I know we solved this one. It's probably when we solved it, Jan 14th. Ooh, exactly a month ago today we solved this. There you go. Given two strings S1 and S2, return true if S2 contains permutation of S1 or false otherwise. In other words, return true. In other words, return true if one of S1's permutations is a substring of S2. This is definitely my last problem. Okay. Well, just check out some of the hints. Okay, so let's do our window size. So our window is of length S1, right? That is our window size. Window size of 2, right? So then we loop over, well, for right in S1 in length in S1, right? Set out left is equal to 0. 2 actually. Right and range length S2. How do we do sliding window technique again? Jeez, I can't even remember how to do sliding window technique. Good thing I'm looking at it again, because I don't really remember. We have an array of... how do we do it? Slide it 2. I'm trying to think here. Well, like, how does sliding window work? If K, sorry, if if S2 left right plus 1 is equal to what are we returning here? Return true. Oh, this should be return false. Oh shit, we're not even using the window here. If window is equal to right minus left. Oh my god, dude. Think, bro. The window is equal. Window is equal to right minus left, and S2 left. Right plus 1 is equal to S1. I'm not sure. Bro, what is going on here? So we're looping through S1. We're looping through S1. We're checking, well, is S1 underscore S1 char equal to 1? Check if they're the same after the first two elements. Bro, what is going on here? Why do we have two separate for loops here? We'll check if they're the same after the first two elements. If S1 is equal to S2, return true. So why are we checking the first two elements? What did I do here, bro? For right in range, length S1, length S2, add 1 to the value of it. Remove left. I'm not talking about that, bro. Starting like this one. Okay. Range length. S2, right? Check while the window to the length of it's zero based, so this won't work. So then this one this cat is so annoying, bro. Like, seriously. Fucking kill it, dude. JK. Cat always tries to run into my room, dude. So annoying. Alright, so initializing the window here. Okay. We can get rid of this. We don't need this, right? We do. Length of S2, but we want to start from the length of S1. Right. Okay, so then we loop through. We want to add, right? So we do. We created our window, so this is what we're looking for, right? So we do mydig si equals 1 plus mydig s2 si 0. Then we want to decrement. Oh, this needs to change, sorry. This needs to be right. Yeah, this needs to be right as well. Decrement. Well, now I need to think. How do we decrement? S to right. It's meant to be S2. Minus equal 1. Okay. If minus S2 right is equal to 0, then we want to delete it, right? S2 right. If 0, delete. Okay, now we want to check, well, if minus 1 is equal to minus 2, we want to return true, or else we want to return false. My friend is calling me. We want to increase our left. They are equal. Oh, this is our left pointer here. It's meant to be left here. Left here, we want to check, well, increase our left pointer. I think we should be good here. Nope. I meant to click wrong. Can I just look where I left? We haven't initialized it. Is equal to 0. Okay. Let's do left. E. Key error E. Why is I think we forgot that. There we go. Okay, we're gonna call it there. Thanks for watching. See you guys later.